وعليكم السلام.
Hi everyone. I hope you are all doing well. Are you okay? Okay. Welcome back to our course, and this is our lesson number 4, I guess. So before we start our lesson, I just want to ask if you have any questions in our last session. It's okay for me. Any question, any problem, any trouble, it's okay. Okay, today we are starting lesson 4 and we're going to learn one of the most important algebra topics in our course because it's very, very, very important. So I want to ask you to concentrate with me. And if you have any question, don't let me go without understanding and without asking me more and more and more. It's okay. I love questions and I like to listen to your voice. So about algebra fraction. Our lesson today about algebraic fraction, and it's not difficult, but just needs some concentration, okay? And it depends on some of our last topics, so I hope you understand it well last session. So let's make as we used to do. If we want to split it into concepts, we just have to know that we have to know simplify algebraic fractions, adding and subtracting algebraic fractions, multiplying and division, and solve equation involving algebraic fractions. And it's not difficult. But before we start, I just want to ask if you know what is the meaning of algebraic fraction. What is algebraic fraction? What is a fraction? The fraction is some kind of numerator over denominator, right? We have something up, something down, and they are taking part together to make a fraction, okay? So, in algebraic fraction, we just want to make what we will see in numerator or denominator some huh, expression, algebraic expression. So, before we see 2 over 3, or 5 over 7 or 100 over 1000, all of them is what are fractions, ordinary fractions, right? But today we are going to talk about the algebraic fraction. What's the meaning of algebraic fraction? Algebraic fraction is simple fraction where the numerator, the denominator, or both contain algebraic expression. What's the algebraic expression? Maybe x, maybe y, maybe x plus 2, maybe y minus 4. It's okay, right? All of them are what? All algebraic expression, algebraic expression. While we see the algebraic expression, we have to see the numerator, maybe x over 4. It's algebraic fraction? Yeah. Why? Because I have the numerator, it was algebraic expression. Okay, I can say 4 over x plus 1. Is it algebraic fraction? Yeah. Why? Because the denominator is algebraic expression. And maybe it's x over y minus 7. Is it algebraic fraction? Yeah. Why? Because both numerator and denominator are algebraic expression. I hope you know what I mean. So if we have algebraic fraction, we have a rule very similar to ordinary fractions, but there is no important difference. Okay? Before we simplify anything, we must factorize. So we have to factorize and we have to simplify, and we will make it very, very easy. So I would just want you to know you have to think first. Whenever you see algebraic fraction like that, you see algebraic fraction here. I will ask you, can I factorize the numerator? Can I factorize the denominator? Do they have any common factor? If the answer is yes, then simplify. So here, look, they have, I can't factorize numerator because it's in its simplest form, and also the denominator. But I can make what? I can have common factor. Yeah, it's x. So there is x up and x down, and there is no plus or minus, right? All the relations here are multiplying. So I can cancel this x with this x and get my answer with 2. Did you know what I mean? So if you have common factor, okay, simplify. If you can factorize numerator, factorize it. If you can factorize the numerator, factorize it, and we will see all the examples. Don't worry. So, my golden rule here, as we used to do, what's the meaning of golden rule? Golden rule means how to solve. How can I solve? Okay? I will say factorize if it can be, then cancel. If you factorize and cancel, you finished your question, but in one condition, you have to factorize fully and you have to cancel any common thing up and down. Okay? Any problem here? So, why I can't factorize here? Because it's individual. If it was individual term, can I factorize? No, I can't. Okay? So, always factorize first if you can. If you can't, ask yourself, is there any common factor? If there is, okay, I can do it here. Cancel them together and you will finish your question. Did you get it? Okay, let's take example to make our golden rule here. Look, if we have something like that, if it was 6x over maybe x power of 2 plus 5x. Okay, before I start to solve, I have to make what? Factorize, then cancel. Is there any factorize in the numerator? No, it's individual. What's the meaning of individual? It's one term. Algebraic expression contains from one term. If it was one term, I can't factorize. Okay? So I can't put anything up. So it will be 6x as it was. Okay, look at your denominator. It's x power of 2 plus 5x. Yeah. Huh? Can I factorize? The first thing in factorizing, do you remember our last session? The first thing in our factorizing is what? Yeah, it was common factor. So I can take my common factor here. What's my common factor? Is there any common factor in numbers? No, there is 1 and 5. There is no. Okay, what about here? The variables. Here is x power of 2 and here is x. So I have to take x. And start to make what? Yeah, very good. It's x. Yeah, and start to make what? To open my bracket. Where is the first term? X power of 2 divided x is going to be x. And positive, it will be as it was. Here is 5x divided by x, going to be 5. Very good. Now, both terms have common factor of x, and I take x as a common factor and started to factorize it. Okay, very good. Now, what is the next step here? Look it up, look it down. I have x and I have x. And this x is not related to plus or minus. Okay? It's very important. So here, it's 6x and down, it's x multiplied by the expression x plus 5. If it was multiplied, the relation here is multiplied, and the relation here is multiplied, so I can cancel. Here, I can cancel this x with this x. Up, it will be 6, only 6. Down, it's going to be x plus 5. Okay? Here, we have a very big common mistake. Some students make what? Some students cancel this x with this x. Ooh, it can't be. Why it can't be? Because this x is related to this 5. X plus 5, they are related. There is one expression called x plus 5. I can't take any step here. Okay? They are connected together. So I can't cancel this x with the x up. I can cancel this x with the x up because it's multiplied. Did you get it? So I make my golden rule. I factorize as I can. I cancel. While I'm factorizing, I'm looking for what? If it was individual term, there is no factorizing. I hope you get it. Any problem here? Okay. So I just wanted to tell you about the exam tip here. Whenever you think you can cancel something, stop and ask yourself one question. Is this a common factor or just a term? As I said here, it was just a term, so I can't cancel this with this, right? I have to make what? I have to ask myself, if it was a term, I can't cancel it, okay? Don't forget it. You cancel factors, not terms. You cancel factors, not terms. Okay? Okay, are you ready for our next step? Okay, let's take another example. Here, 4x plus 6 over 2x squared minus 7x minus 15. Who can remember our last session? Who can start to help me to factorize it? Hmm. Okay, look it up, numerator. Can I factorize it? It's not individual. Okay, look at the common factor. Is there any common factor here? About numbers? Yeah, there is. Why? Because there is 4 and there is 6. So I have to take what? I have to take common factor from 4 and x and 6. Yeah, I can take 2. Why I can take 2? Because both of them are even number. So if you take 2, look at the variable. Here is x and there is no x here. So I can't take x as a common factor. Then open your bracket. Here, it seems like 4x over 2 gonna be 2x plus. Here is 6 over 2 gonna be 3. And you finished the up. What about down? Who can help me? Is there any common factor here? Hmm? Is there? I guess no. Hmm. Okay. So I have to look for what? I need your help. I need to put two brackets here. I want to split 2x squared into two terms. If I multiply them together, they will give me 2x squared. Of course, it must be 2x and x. Here, I want to split this 15 into two numbers. If I multiply it, it's gonna make 15. But look at the terms outer and insider here. Look at this 15. Can I factorize it into 5 multiply 3? Yeah, I can factorize into 5 multiply 3 or 3 multiply 5. Okay, if I put 3 here and 5 here and make it in my pencil to ask myself, look at the inside. Here is 3x and here is 10x. Yeah, if I look for the third sign here, it's going to be negative. What does it mean if it was minus? If it was minus, so I'm looking for two numbers. If I multiply them together, it's going to make 15. And insider and out terms, if I take it together, they have to give me 7 if I subtracted them together. So here, it's a 3 and 10. Yeah, it's going to be 7, so it's right. What about signs here? About sign, if this sign was negative, huh? I have to know what the two brackets have different signs. One is positive and the other is negative. Which one will take here? Will take the sign of the middle, the bigger one, which is what? Which is 10. So gonna be here negative, and the other one will be positive. Huh? Get it? If you understand our last session, you can make it very easy. So then I factorized. Look, is there any simplifying? Is there any canceling? Huh? Look, yeah, I have common 2x plus 3 up and 2x plus 3 down. So I can cancel them together. Okay, finally, I will take up what? I will take only 2. And down, it's gonna be x minus 5. And I finished my question. Hmm? Get it? Any problem? Okay, now we're going to take the next concept.